Okay, this video I'm making is going to be explaining myosin and actin. And myosin and actin are the two components that make up a myofibril. So I'm going to do my best here to remember that the myosin is going to be in red. So I am going to draw my myosin in red. And myosin is a fiber that has a myosin head on it. All right, so if I look here to this picture with the purple here, okay, I scribbled through it there, but if you notice, I'm going to do a white line and the head, okay? So I'll do that again. Hopefully you'll be able to see that, and excuse my dog's barking, the mailman's here. Okay, so there's the myosin head, and I'm doing that in red over here, so that way you can see what I'm talking about, all right? And then there's the actin, and the actin's going to be the thin filament. And in the picture that I was referring to, it's going to be that orange line. And you'll notice that orange line runs above the myosin. Now I put my two touching, so I'm going to go ahead and erase that and redo that because I do not want them touching. Okay, so they should look something like we see in the other side of, like we see in this picture here. Okay, so we have actin and myosin together making myofibrils. Now, I have drawn one little section, and I am going to use my pen here to show you that I have myosin and actin. And when I drew one blue line, that would be similar to one blue line. And when I drew one red line, that would be similar to one red line. Now I put my blue and my red over one another, and that would be a muscle in contraction, meaning the muscle is squeezing. And these two chemicals are going to slide past one another. So I will go back and draw some more myosin because the myosin actually ends up being a number of these little heads. And you'll notice as I draw more little heads here, the center portion keeps getting thicker. And this is why we call it the thick filament, because it does end up looking thicker, okay? And then on the actin, the blue line, I'm going to draw these pink dots along my blue here. So that way you can see, look at these right here, pink dot, pink dot, pink dot, pink dot. Those are what I was trying to represent here by these little pink dots on the blue line, okay? So we have actin and myosin, and the two of them work together. There is a chemical attraction in between the myosin head, which I've now circled in white, and the actin thin filament that I've now colored out in white. And this little yellow part right here is going to be attracted to this little part right here. And they're not always attracted. You can see right now that they are far from each other. They are not close at all. Now, what's going to happen is in order to make the connection between the myosin head and the actin, this whole molecule right here is going to need to roll over. And when it rolls over, these active sites are going to come closer to the myosin head. And when they do, there is an attraction there because of the chemicals, because of the shape of the chemicals, because of the polarity of the chemicals. Those two things are going to automatically join. And when they do, this myosin head is going to contract. Okay? So we're going to talk about sarcomeres now. And a sarcomere is going to be the structural unit of a muscle fiber. It's the contractual unit of muscle fiber. So together, the myosin and the actin are going to play a like game of tug of war. They're going to grab on, they're going to pull each other, they're going to release each other when the time is right. And that whole contractual unit is called a sarcomere. So if we look, we can see that in my little diagram here, it shows us the myosin. Okay, remember the myosin is going to be here. And if I were to draw the myosin with what I see right there, it would be that center line that it has, okay? And then notice it has one part coming out this way and one part coming out this way, and one part coming out this way and one part coming out this way. So I am trying to draw what I see right here by drawing a line to the right and a line to the left. And the myosin fibers are all attached to this backbone, I called it earlier. I'm sure it has a name, but we don't need to know that for our level of understanding, and it's not labeled here, so. Okay, so that's the myosin. So now I'm going to add to my drawing, and as I add to my drawing, I'm now going to add the actin lines. And remember, the actin I've always represented in blue, and as I come down here, it's going to be those little lines. And notice, here's what I just drew. Okay, that's what I just drew. And now I'm going to add my actin lines. So I'm going to add this line here, and then I'm going to add the fibers going towards the myosin, all right? And you'll notice if I erase this right here, I want you to notice where I was working before, that this right here is a Z line, thus the name Z line, okay? So it's going to go down, and coming off of my Z line is going to be my actin fibers. I did not draw these the correct size for one another, but I'm hoping that you get the idea. Okay, so the actin fibers go in between the myosin fibers, and here we have no overlap. We have actin only. Okay, and then as I look, I'm going to see here that I have myosin only. No overlap. But what I want you to notice in the middle is that this whole section right here is the zone of overlap. And that zone of overlap, if I were to take a knife and I were to cut this, and I were to turn and look at it, I would see the actin and the myosin, the actin surrounding the myosin, or the myosin surrounding the actin. Okay, so we see the myosin, the zone of overlap, and the actin. And what I want to bring your attention to is that this myosin right here that we see at the top right of the screen, okay, we exemplified it this way, or I did, okay. Now if I look down and I follow this down, this is what is being shown right here. So if I look at that, notice that there's that M line in the middle, and then there are the pieces coming out either way, which I already explained, all right? So hopefully that makes sense to you. And if I look at one individual fiber here, one individual fiber, it would look like this right here. Okay, so we see all those little myosin heads we talked about. When we look at each individual little thread that's there, okay, when we look at those threads, we can see the detail. And when we look at that detail, it looks like this right here. And if you remember, that's what I was saying. It has the myosin head, and those add up together to make the thick filament, which we called myosin. That myosin is connected in the middle of the M line, and that is that. Okay, so now as I look back up here and I think about the actin, remember the actin is the blue lines here to the side, and when I look at this here, I'm going to be looking at this part here. Okay, this part here, if I look right here, this is what it looks like on its own with no myosin at all. So I am going to erase all of this so that way I can focus in on the actin right here. Okay, so the actin right here is what we were looking at, and sure enough, that's what we see right here. We can see the Z line down the middle right there, and we can see the Z line down the middle right here. Okay, so the Z line from Z line to Z line is a very special thing, and it's called the sarcomere, and that's what you really need to know right now, but you needed to know what the sarcomere is made up of. So here is a Z line, and here is a Z line, and in between the two Z lines is the sarcomere, okay? So what we're going to look at now is we're going to look at this sarcomere up here. Boom, sarcomere. We have our actin, we have our myosin, and we have our sarcomere, all right? Now, as I back out of this being close up, you can see the repeating units, and those repeating units make up the myofibrils. The myofibrils, we said, are repeating units of sarcomeres. So the next thing we're going to have to figure out is how are those sarcomeres stimulated? It has to do with the sarcoplasmic reticulum and how the sarcoplasmic reticulum releases calcium. We all remember, hopefully, how calcium plays a role in action potentials because that's going to be the same process at work when we talk about skeletal muscle contraction.